Welcome to EducAgent Studio, where a crew of AI agents help us teach and you learn with ease. Here's the problem we'll solve today. We are given three numbers whose sum is 0 and two vectors v and w formed by permuting the entries. Part A asks for the angle between v and w using the standard cosine formula from linear algebra. Part B challenges us to explain why the dot product ratio is always -1/2. Pause and think. Can you see a symmetry or algebraic identity that forces this value? Compute the dot product by multiplying corresponding entries and summing. Because addition is commutative, we can rewrite the sum as xy plus yz plus zx. Keep this expression in mind. The next step links it to the sum 0 condition. Square the sum x plus y plus z. Since the sum is 0, the square is 0, and expansion gives a relation between the pairwise products and the squares. Solving for the pairwise sum gives -1/2 of the sum of squares. This is the key identity. Substituting into our dot product expression yields this compact formula for v.w. Because w is a permutation of v, their squared norms are equal. Both equal the sum of squares, so the norms match. Forming the cosine cancels the common norm factors, leaving a constant -1/2, independent of the particular non-zero triple. This illustration uses a representative pair of vectors that satisfy x plus y plus z equals 0. Those two vectors meet at an angle of 120 degrees, which corresponds to cosine equal to -1/2. Quick recap of what we learned. For part A, the cosine is -1/2, so the angle is 120 degrees, or 2 pi over 3 radians. For part B, the algebra shows the dot product equals -1/2 the sum of squares, and identical norms cancel, producing the constant -1/2 for any non-zero triple summing to 0. If that was satisfying, stick around. In the next video, we'll explore other elegant identities that force fixed angles between vectors. Watch the next video to learn more.